Hi, chemistry students. So this is your lecture on measurement and chemistry unit on significant figures. And if you haven't already, you should have a sheet of notes that you picked up at the door or that you have with you. It looks kind of like this, or it looks exactly like this. Unit 2 notes on PowerPoint 3 significant figures. So if you didn't pick it up, it should be at the door if you're in the classroom, or hopefully somewhere in your binder if you're at home. So this is the thing that you should have. And there's not a lot of writing with these notes. There's mostly just looking and thinking about things. All right? So once you're set, pause the video if you're not. Once you're set, we'll get going. And I'm going to disappear now. And you can see the first slide. So this is actually a two-part lecture. We're just going to do part one here right now, which is identify and count significant figures. Talk about what significant figures are. All right, so here's the deal with significant figures. It deals with accuracy of our measuring device. How good is your measuring device? And in science, it's important to be honest. And you're not supposed to cheat and give a number that's better than your instrument can record. So let me give you an example. What do I mean by this? So if you look on your notes, it says model for, and this used to be a POGL, ruler A, but I like just going through it a little quicker. It was a little bit of a tedious POGL because you get the point here. So here's ruler A. Not a very good ruler, right? It's just marked at 0 and at 10, and I want to measure this little piece of wood. All right? So notice what it says in the model here. It says these are valid measurements. Okay? So I think we can all agree that I can say it's either 2 or 3 centimeters, but I don't know that for sure. I'm kind of rounding to that number. Those are considered valid measurements. What would be considered dishonest, invalid measurements is if you reported using this ruler that this wood block was, say, something like 2.5. Well, how did you go all the way to the tenths place? You don't even have a ones place marking. How do you know that? How are you going all the way out to the hundredths place when you don't have even a tenths place marking? So the only honest measurements, these would be invalid. This would be dishonest. Your measuring device is not this good. It's only this good. All right, now how can we make the measuring device better? Well, let's put some more marks. So look at ruler B, okay? So same piece of wood, but now we've added the ones place, okay? So we can now see that it's definitely 100% certain it's 3. And then we can see maybe it's just a little bit above 3, so I can estimate the next digit. These are considered valid measurements. What's actually marked and also the first estimated digit, okay? Now, I don't have a tenths place though, so these are considered invalid. So I can't go out to the hundredths place if I don't even have the tenths place marked. Now this one, you might say, well, why can't I do this one? Because that is not giving your ruler credit. We know it's 3, but that's not an estimate like you had in ruler A. That's a definite number, and you can see it's a little above 3. So this is not, you're not giving your ruler credit. All right, so how can we make it even better? You're right. Let's add some more marks. Here's ruler C. Now we've added the tenths place. Okay, so we have the tenths place mark. And if you had really good eyesight and can move it up here, you could see that we now consider valid measurements. Again, the ones place is marked, right? They're the big lines. The tenths place is marked. They're the little lines. And we can estimate one more place. And that's considered a valid estimate. A valid measurement. We can report it honestly this way. It's invalid though. Here we're not giving our ruler enough credit, and here we're giving it too much. We can't go out to those places because they're not marked. All right, so again, the idea is in a valid measurement that the last place is the uncertain digit, and the rest of the digits are certain. There were markings, or we know they're for certain. So if you look on page 1 of your notes, you'll see at the bottom number 10. Again, this was a sort of shorter POGL. And you're going to fill in these blanks. It says in a valid measurement, you record the blank estimated digit. In a valid measurement, the estimated digit is the blank in the measurement. And in a valid measurement, the estimated digit corresponds to the blank on the instrument. So you may want to pause the tape and go ahead and see if you can circle your answers there on page 1 of your notes. And then we're going to check it. So pause if you don't want to see it because I'm about to change the slide. So in a valid measurement, one that we consider honest and valid, you record one and only one estimated digit. So one beyond the markings. In a valid measurement, the estimated digit is the last digit. That makes sense. And in a valid measurement, the estimated digit corresponds to the next place, so 1/10 of the smallest mark on the instrument. Okay, again, I want to emphasize why this is important. We want to be honest about our measuring device. So if we weigh something in our science experiment for a science fair project using this kitchen scale might only be accurate to the nearest gram. So we would not want to be reporting our weight as something out to the thousandths or the 10,000ths place, because that's not honest. Our scale isn't that good. On the other hand, if you're taking AP Chem, you have to use one of these. This is about a $2,000 scale. It could go out to the thousandths place, or actually this one goes out to the 10,000ths place. So we can then have our measurements out that far to those places, and we want to be honest about our measuring. Again, it's important to be honest when reporting a measurement so that it does not appear to be more accurate than the measurement allows, than your measuring device allows. We report something called significant digits or significant figures. And let me explain with an example. And actually, all we're going to do for this presentation is once we have measurements, we have to literally count how many of the digits are significant. So a significant figure, a digit is considered significant. Any digit that is actually measured or estimated is considered significant. So let's go through this. So here's a line we're measuring on this ruler, and we're going to just ignore the millimeters down here. So we can see that our last marked spot is the ones place. So that is certain. It's actually measured. The tenths place is the estimated place. So we could honestly say that this is 3.2. We have one actual number and one estimated number in this particular measurement. All the actual numbers and one estimated number. So to count significant figures, you just literally count. I've got 1, 2 digits there, 2 significant figures in this particular measurement. So we're going to just practice. We're going to learn how to identify whether a digit in a measurement is significant or not, and then we're just going to count how many in the measurement there are. So again, the idea is you're counting all the actual digits, the ones that have marks, and the first estimated digit. So see if you get this. How would you honestly report the measurement of this little piece of wood based on your measuring apparatus? Now, your measuring apparatus is marked to the centimeter, okay? So that's the actual measurement. But remember, we can also estimate. So if you count these marks, you can see that this is 1, 2, 3, 4, 5, 6, 7, right? So it's 7. And we know that for certain, but we can estimate. So after the ones place comes the tenths place. Now you might think this is exactly 7, but no, we're rounding to something. It looks like it's 7. So if we're going to the tenths place, but we want to say it's 7, and at the tenths place, which of these measurements would you use to be honest about the length of this wood splint? Okay, remember the last digit is estimated. So is the 7 estimated? No, it's not. Is the 0.0 estimated? Yes, it is. All right. Now, we can't go beyond that. All right. For the actual measurement, 1 beyond. So the right answer for this would just be 7.0. Okay. Now, when you're using a scale, there's not like a line like you would have on a graduated cylinder or on a ruler. When you're using electronic scale, if you recall when we've used them before, this last digit, the 0, tends to fluctuate. So on a scale, we always consider the last digit the estimated digit anyway. So this would be the equivalent of 3 significant figures. 1, 2, 3. These are the 2 first actual ones that are measured. The last digit is the estimated. So this would have 1, 2, 3 significant figures. Okay, so if you turn the page, oh, you should have done that already because that's where the ruler was. If you turn the page in your notes to page 2, you'll see at the bottom it says Rules for Counting Significant Figures. Put a big star next to that. Put a double big star next to that. You need to know these rules. It's like you try to teach someone a card game and they refuse to learn the rules, and then it's no fun. Believe me, you're going to be using these rules throughout all your data collection if you're doing a science fair project, and in the class and in physics and beyond if you're taking any sort of physical science. It applies to all those classes. Learn it, okay? So the rules for counting significant digits. Let's just go through them and then we'll go through some examples. So if you see a measurement, and remember these have to be with measurements. This makes no sense if we're talking about just numbers. It has to be with a measurement like a gram or a kilogram. It says no, non-zero digits are always counted, are always significant. Any zero between two significant digits are significant. They're called sandwich zeros. Placeholder zeros in front of a decimal are not significant. All right? And when there are final zeros in a measurement, the zeros are only significant if the number contains a decimal point. Finally, exact numbers, like counting numbers, like 4 apples. Remember, these significant digits are supposed to tell you how good your measuring device is. So exact numbers such as 4 apples, can you count apples pretty accurately? Is it, when you count 4 apples, is it like almost 4 apples? Or maybe a little bit over? Is it 4.1? Is it any sort of a rounded number? No, you could put 0.0 and infinity after that because you're such a good counter. So any exact numbers where they're not like units like grams or liters, and it's not on a measuring device, they're considered infinitely significant. Also, definitions of units, like 1 gram is 1,000 milligrams. These are definitions, so they're considered infinitely significant. Okay, best way to do this is to look at some examples. All right, now I want you to think about the fact that the only time a digit isn't significant is possibly in 2 circumstances when there are zeros. Okay, so we're just going to have some examples here. They're at the bottom of the page. Really think about them. Look at them because I'm going to ask you to, on page 3, to do some examples. So if you have the measurement 1.33, those are all, this is rule 1, those are all non-zero numbers. 1, 2, 3 digits, 3 significant figures. All right, now here's a 0. You always have to be careful of zeros. But if you go back to the rules, you can see any zeros between 2 significant digits are significant. They're called sandwich zeros. So notice that this 0 is in between. It's like a sandwich. So we count it. So 1, 2, 3, 4. Okay. Now, here's the next one. You've got zeros again. All right? They're at the end of a number. Now, why did we put them there? Where's the estimated digit? It's the last 0 there, right? So we put it there to tell us that our measuring device was that good. If we omitted them and just put 21, then we'd say the measuring device was only good to the ones place. So it's important for bragging rights here to make sure that we include all these numbers. So again, if you look at the rules, you can see when there are final zeros in a measurement, the zeros are only significant if the number contains a decimal point. So in this case, it does contain a decimal point, and it's a final 0, and therefore these are all significant. All right, now this is where it gets a little tricky. Do you see these zeros up here in the front? They're called placeholders. Now this is a fabulous scale. It goes out to the thousands place, but we're only using the last 2 digits of this scale. All right, so even though, and we have to have these zeros here, or we have to write it as an exponent. And notice if we wrote it as an exponent, 2.1 times 10 to the negative 2, that these zeros would disappear. They're just holding a place. So this is one of 2 times when the zeros don't count. This is a great scale if we were measuring a gram or something like that, but it's not a great scale if we're measuring 0.021 of a gram. It only has 2 significant figures. Okay, now let's look at this one. Again, we have these placeholders, but how much of the scale are we actually using? Well, we're using 1, 2, 3. This is a final 0 with a decimal in the number. Okay? This is the estimated digit. That's what the last digit always is, and we want to make sure it's there. So this would have 3 significant zeros, or figures. Sorry, that's a little bit of a typo. So here's 2100, okay, kilograms. Now I want you to think about this. Where is the estimated digit in this number? Well, you say it's the last one, but we have to have these zeros to represent 2,100. So could the estimated digit possibly be the 1? Or could it be this 0? Or could it be this 0? It would be impossible to tell. So we need to just assume the worst. So again, if you go back to the rules, you see final zeros in a measurement. The zeros are only significant if the number contains a decimal point. And you can see that this number right here does not contain a decimal point, and so that's why we consider it just 2 significant figures. This one, on the other hand, okay, has a decimal point, all right, just like this one does. And so we do count these zeros. So this has 4 significant figures, okay? So the trick about counting these things is just to check the zeros. Do you have zeros like this that are at the end with no decimal? They don't count. Or do you have zeros like this at the beginning of a decimal? They don't count. Otherwise, you count the digits. All right, so if you turn to page 3, there are a couple of ones for you to look at. So take a minute, pause the tape, and try to do the questions on 3, and then we're going to check them. I'm not going to pause, but you can pause the tape. Really, do take your time going through this. So here's a measurement. Pretty good scale here. What kind of zeros are these? Look at your rules. These are sandwich zeros. They're in between digits that count. So all of these count. So you should have gotten 5 significant figures. 1, 2, 3, 4, 5. All right, let's look at the next one you had to do. 0.011 seconds. So this would be great if we were measuring whole seconds, but we're using just the last 2 bits of this. So what are these zeros? These are placeholders in front of a decimal. This is one of 2 times when zeros don't count. So this one, we're just using the last 2, so you have 2 significant figures in that measurement. Next one is this. Now we have 2 kinds of zeros here. We have placeholders. They're not significant. But we have a 0 at the end of a number that has a decimal in it. So again, that's telling us this is the uncertain, not the 5. So that means we have 1, 2, 3 significant figures. Okay? And then finally with these, again, let's analyze this. We've got 5,000. Is there a decimal in the number? No. Okay? So it's only going to have 1 significant figure. 5 apples, this is a counting number. Okay, we know we have exactly 5 apples. We could put 5.0 on to infinity. We have exactly 5, so that's considered infinite number. Okay, so 5,000 has just 1 significant figure, but because it's a kilogram, it's a measuring unit, whereas 5 apples, which is a counting thing, has an infinite number. Okay, so if you wanted to take the 5 rules and just take them down to just 2, pretty much everything counts except zeros in these 2 unique circumstances. You don't count zeros that are placeholders. Okay, so like all these zeros here, this is a great scale, but boy, we're only using, that 2 is even estimated. It's not a great scale for what we're doing. It has only 1 significant figure, whereas this, okay, 1, 2, 3, 4, you're not using the placeholders here, has 4 significant figures. Whoops, let's go back. And then the other circumstance, so placeholder zeros don't count, is when you have final zeros in a number without a decimal point. So again, this doesn't have a decimal point, so we don't count these final zeros. So that's just 1 significant figure. This, again, doesn't have a decimal point, so we don't count this last 0. So it has 2 significant figures. Okay, again, we should emphasize that this is if you had measurements on them. So I should really have grams and liters and such on them. But if I have a decimal here, it does, so they're going to count. That's going to have 3 significant figures because this last 0 is the estimated digit. Or if I go out this way, 500.0, again, this is the estimated digit. So that's going to be 4 significant figures. So just a couple of quick ones. You've got this. Again, you got to analyze the zeros. These are always, 6 and 7 are always going to be counted. Do we have a decimal in the number? They're final zeros. No, we don't. So 2 significant figures. This time we do have a decimal. So it's telling us that that 0 here at the end is the uncertain digit. So we have, this case, 4 significant digits. Here's another one. We've got some placeholders. They don't count, but we've got a 0, that's our estimated digit, in a number that has a decimal point. So the answer to that would be 2 significant figures. Okay? I just want to remind you that if you have to round a number, and you sometimes have to do, they'll say round to a certain number of significant figures. Remember that numbers greater than 5 will round up, numbers less than 5 round down, and that you just kind of drop the 4 or less, and numbers equal to 5, in our case, we're going to round up. All right? And so what I'd like you to do now is you finish with this little part of the presentation. We finished part 1, and in this learning module you will find a diagnostic quiz on significant figures. you're to take it. You're to go there, open it up, take the diagnostic quiz. As soon as you're finished with it, and it's a participation grade, as soon as you're finished with it, you'll get to see your answers. You'll get to see how well you did. Now, if you didn't do well, there is a video for you to watch. Okay, so if you didn't get 100, I would like you to watch the video that I'm also going to post in this folder. All right, and I want you to be sure that you write down some examples on your note sheet. Now you'll notice we haven't finished with this note sheet. We still have to do part 2. So save that for the next class, and thanks for listening.